So for the first step, we need to open the application first. This is the application SFOPT. And here it is. This is the application. So the name of our product is Spheroidal First Order Polarization Tensor Calculator, or the acronym is SFOPT. Over here, we have some description about this calculator. So this application calculates the first order polarization tensor for two types of spheroids, which are prolate and oblate spheroids. So how do we classify which one is a prolate and which one is an oblate spheroid? It is by considering the semi-axis. So for this purpose, this application will only consider the spheroid with semi-axis A greater than B equals to C, which can be classified as a prolate spheroid, and A less than B equals to C, which can be classified as an oblate spheroid. So basically, the semi-axis A and B can also be referred to the size of the spheroid itself. So over here, the first order PT in this application can be calculated if the conductivity denoted as small letter k and the semi-axis of the spheroid are known. So there are two functions in this calculator. The first one is to calculate the first order PT for spheroid. As I mentioned earlier, there are few informations required in order to calculate the first order PT. The first one is the conductivity and the semi-axis of the spheroid. So let's say if the conductivity is 2, the size of the spheroid, let's say A is equals to 0.5, B is equals to 0.2. So the size, it will be in meters. So when we click calculate, it will calculate the first order PT for this specific spheroid. And it will classify the type of spheroid that we have based on the semi-axis value. Okay, this is the first order PT for prolate spheroid, where the first order PT is given in the form of a 3 by 3 matrix over here. Let's say if we change A equals to 0.2, B is equals to 0.6. When we click calculate, it will recalculate and reclassify the first order PT and the type of spheroid that we have. So over here, this is the first order PT for oblate spheroid. So this is the first function. For the second function, this calculator can calculate the size or the semi-axis A and B of a spheroid from a given first order polarization tensor. So the given first order polarization tensor must be a 3 by 3 matrix, and it must be in this form only. So we can always find the best fitted spheroid by specifying the conductivity value over here. So how do we specify the conductivity value? It must be in accordance with the results or with the findings from the second reference over here. M11 over here is the value of the element from the first row and the first column from the given first order PT. And M22 over here is the value of the element from the second row and the second column over here from the given first order PT. So let's say this is the given first order PT. So M11 is this one. M22 over here, the value of K must be in accordance with the findings from the second reference over here. So let's say M is equals to 5. So we click calculate. So A is equals to 0.23, 0.36. As we can see, we have a different value for A and B over here, as well as K over here. But then again, two spheroids have equivalent first order PT, which is this one.